Welcome to Regis Pre-Algebra, Lesson 21A. We are in Chapter 4 Review. The section is 4.33. Now please do recall that on Wednesday you will have a Chapter 4 test. The first thing they're asking you to do is to be able to write an expression. So in writing an expression, for instance, if we say 3 times x to the 4th power, we would simply, if we said that in English, we would say 3, a number next to a variable means times, right there. So 3 times x to the 4th power. So that would be the first concept. We're skipping over some things. We're going down to 11, and the second number 11, and the second concept would be if you are creating a table, and your x values are going to be, in this case, my dependent, capital X, and my y would be my independent. Now recall, when it's independent, that's the one that's on the right side typically. If we have x equals 4y minus 2, the y would be independent. That means that I get to plug in my values, and my x would be my dependent, in this case my capital X, and that would mean that it's dependent on the values of the y. Okay. So if you have values, for instance 0, 1, 2, etc., for each y, you would first plug in a 0, and you would get 4 times 0, or 0 minus 2. I would get 4 times 1, or 4 minus 2 is 2. I would get, that's going to be a 2 there. I would get 4 times 2, or 8. 8 minus 2 is 6, etc., etc. So I'm calculating my values here based upon the values they give me in the book on the top line. So you have a couple of assignments like that. The next section, number 13 through 22, is sign numbers. A couple of you are still struggling with sign numbers. You need to make sure you understand the rules. Okay, if I'm thinking a plus, I mean, whether a negative or positive, it could be -3 plus -7, or it could be -2 plus +4. Doesn't matter whether the ones in the parentheses are negative or positive. You want to think number line, okay, in your mind. Okay, and if you will just trust me and continue to think in your mind what it looks like, which direction am I going from 0? In this first example, I'm going to the left 3 and to the left 7. This will be -10. If I'm going to the left 2 and to the right 4, I'll be going to the right more than to the left, so it'll be a +2. Okay. And you really want to study this. So the first thing would be to know how to add. The second thing would be to subtract, and always convert a subtraction. Convert to a plus, to an addition of the inverse. So what would that look like if I had a -3 minus -2? This is my operation, a subtraction. Change it to an addition. So copy everything down in the first part, just like you see it. Change that to an addition, and change the second number to the inverse. What is the inverse of -2? +2. Then you go back up to addition. So in this case, I would have -3 plus 2. I'm going to have to take the difference of those because I'm going in opposite directions, and I'm going to end up with -1. Now, it's very, very important that you nail this concept, because these two ideas will form the foundation of algebra. And if you can't get this down, you will continually miss your problems. Okay, evaluating, starting with number, oh, and I'm sorry, before we get to that, multiplication and division have the same rules. Same rules. Even number of negative signs, the answer will be positive. Odd number of negative signs, and even number of negative signs or no negative signs, maybe that goes without saying. Odd number of negative signs, the answer will be negative. It doesn't matter whether I have 2 or 10. I could have something like this. -5 times -2 times -1 times divided by +4. I'm counting up negative signs. I have 3 negative signs. That's an odd number of negatives. My answer will be negative. Now I just look at numbers and I'm ignoring signs. 2 goes into 4 2 times, and my answer is 5/2. Just like that. For either for either multiplication, division, or a combination of it. Now your evaluation, beginning with number 23, you want to go ahead and plug in every value, making sure that you are paying attention to the operations. In other words, if I have y squared minus m times n, or mn, whatever y equals, I'm going to square it. Let's say y equals 2. M equals 3, and n equals -1. Okay, I can do this kind of in my head. If I want to think y squared, look at the y value. Y is 2, 2 squared is 4. Look at m times n to the right. M times n is a positive times a negative. That will be negative, and 3 times 1 is 3. And then this becomes, change up subtraction to addition. The inverse of -3 is 3, so my answer is 7. So again, your need to know signs is paramount. Simplifying polynomials, remember on 26, all we need to understand is for things like that, 26, 27, and 28, is the idea that to simplify, when we have addition and subtraction, which we do on all 3 of these, we need to think like terms. So now all we have to do is worry about sign numbers for addition and subtraction, and only combining like terms. Okay. For solutions, which is 29 through 34, your basic idea is simplify the left side of the equation, simplify the right side of the equation, and then we want to isolate the variable. Isolate means when I'm done, I only want x equals or y equals all by itself on one side of the equation. X equals something, right? Just like that. All right, so how do I isolate the variable? You're always doing the opposite by doing the opposite operation. So, if you have x plus 7 equals 14, the opposite of adding, I would subtract subtract 7. The opposite of adding 7 is subtracting 7, leaves the x alone. 14 minus 7 is 7. If I had 3 times x equals 9, the opposite of multiply, I'm multiplying by 3, is to divide by 3. I get x, 9 divided by 3 is 3. If I had x minus 2 equals 4, the opposite of subtraction is addition. 4 plus 2 is 6. If I had x divided by 3 equals 7, the opposite of division is multiplication. 7 times 3 is 21. So that's the basic idea there. If you had them both a multiplication or a division, and a subtraction or an addition. Let's get another number in there. First, I would do the subtraction or addition. So in this case, I'll subtract 5. X over 3 equals 7 minus 5, or 2. And now I'll do the opposite of division. X equals multiply. 2 times 3 is 6. So the order is very important. First the addition and subtraction, then the multiplication or division. Don't forget that if you have a fraction, for instance, 2 sevenths times x equals -3. The opposite of multiplying by a fraction is to multiply by the reciprocal. So I would say -3 times the reciprocal of 7 or 2 sevenths is 7 halves. There's nothing to cancel, so I'd simply multiply numerator times numerator, -21 halves. If I have more than one fraction on the left side of an equation, or on the same side as I have the variable, I'm going to want to multiply all to get rid of fractions. I'll multiply by the least common denominator. And to get rid of decimals, I will move everything over the largest number of decimal places to the right of the decimal point. And don't forget, for both of these, you must do it to every term. That means if I have 3 terms on the left and 2 on the right of the equal sign, I better be doing this 5 times. Every term must be treated the same. Both sides of the equation. When we're reviewing our square roots, okay, we're asking myself, I'm going to take the same sign as what's up front. If there is no sign, I'm going to make it positive, because that's the principal. Square root is positive. Okay, so here my sign will be negative, and I'm asking myself, what times itself equals 100? Well, 7 times itself is 7 times 7, that would be 49. 9 times itself would be 9 times 9, or 81. 10 times 10 is 100. So these, you should be able to do all of these in your head. I do not want you using the calculator for these. Okay, if I have plus or minus, again, my signs will be the same as they give me. And if 10 times 10 is 100, 11 times 11 is 121. You should know these, have these memorized. 215, and 12 times 12 is 144. So my answer will be plus or minus 12. You're going to skip extracting the square root, and that's actually the end. So that's a brief summary of the entire chapter. Go back and review any sections that look a little confusing to you still.